Welcome to this online lecture on partial molar properties and compressibilities. In this lecture, we will see how to determine the partial molar properties, particularly from the graphical method and the applications of these partial molar properties. Let me share the screen with you. I am Dr. Santosh Deosarkar, and today we will see the partial molar volumes and partial molar compressibilities. The outcome of this lecture includes apparent molar volume and compressibility, determination of partial molar volume and compressibility, transfer properties, temperature and co-solute effects on these partial molar properties, and different type of interactions involved in the solution, and that interaction, how they are reflected in these properties that we will see. As we know that these are the standard equations for the determination of apparent molar properties, like apparent molar volume, which is V2 phi, is equals to m by rho plus 1000 m rho 0 into rho 0 minus rho, where in this equation m is a molecular weight of a solute, rho is a density of solution, and this small m is a molality of solution. So if you know the molality, that is concentration of the solution, and density of solvent and density of solution, then we can determine the apparent molar volume of the given solute in the solution. Likewise, the apparent molar isentropic compressibility can be calculated. So Ks2 phi, that is the apparent molar isentropic compressibility, which is equals to 1000 into Ks rho 0 minus K0 rho divided by m rho 0 plus m into Ks divided by rho. Here again, rho 0 and rho are the densities of solvent and solution respectively, and capital M is a molecular weight and small m is a molality, concentration of the solute, whereas Ks and K0 are the isentropic compressibilities calculated from the ultrasonic velocity and density of solution. By using these two equations, we can calculate the apparent molar volumes for a given solute in a solution, and for different concentration of that solute, we can determine the apparent molar properties. Now, it is generally observed in case of many electrolyte and non-electrolyte solutions that the partial molar volume and compressibility are determined from the linear dependence of the apparent molar properties on square root of the concentration, as shown in these two equations. For example, the apparent molar volume changes with square root of the concentration linearly and gives this linear equation. Similarly, the isentropic compressibility also is linearly depend over the molar concentration of the solution. So therefore, by fitting the data of apparent molar volume and apparent molar isentropic compressibility to these equations, we can determine the partial molar volume and partial molar compressibility. So for that, one has to plot the graph of apparent molar volume versus square root of molality, and apparent molar isentropic compressibility versus square root of molality. The intercept of the graph respectively will give the partial molar volume and partial molar isentropic compressibility. These are the intercept, and slope of the graph will give you SV and SK respectively, which are the parameters corresponding to the solute interaction in the solution. And these two parameter partial molar properties gives you the information about solute solvent interactions. Now, once the partial molar volume and partial molar compressibilities are determined, then their values in the aqueous solution of co-solute and their value in water. When you take the difference of that, then we get the transfer property. For example, delta T V250. This is a transfer volume or transfer partial molar volume, which is nothing but the partial molar volume. Just now we have determined from the graph partial molar volume in aqueous solution of some co-solute minus partial molar volume in water. Likewise, the partial molar isentropic compressibility in aqueous solution and partial molar isentropic compressibility in water. Their difference gives you the transfer isentropic compressibility. These transfer properties and partial molar properties have their own significance in the determination and understanding of different type of interactions in solution. When we see the basic concept of this partial molar volume, in order to understand how the molecular interactions that are taking place in the solution affect the physical properties and particularly the partial molar volume or compressibility, to understand that, see this example. Here I have shown the two solutions. In the first solution, we have taken excess of water, say for example 100 ml of water, and in which we are adding 1 mole of water. 1 mole of water means it is 18 gram or 18 cm cube of water, because density of water is 1. So when we put 18 cm cube of water in excess of water, 100 ml of water, then the total volume of the solution becomes 118. And like that, volume is additive property, so therefore it will get added. But when 1 mole of water, that is 18 cm cube of water, is added in excess of ethanol, say for example 100 ml ethanol, then the volume does not become 118 cm cube, but it becomes 114 cm cube. So this is because when water is added in the water, then both the water molecules are same and it will get just added to it. Whereas when the water is added in the ethanol, then water molecules are different than the ethanol molecules. So therefore, some kind of interaction take place between the two different molecules, water and ethanol. Ethanol has its own hydrogen bonded structure, water has its own hydrogen bonded structure. When water is added in ethanol, hydrogen bonding between water and ethanol, that is intermolecular hydrogen bonding between the water and ethanol, will take place, as well as dipole-dipole interaction between water and ethanol will also take place. Just see this, the interactions between water and ethanol. As shown over here, dipole-dipole interaction can exist between water and ethanol. Both the molecules are polar and therefore they have dipole moment. They can interact through the dipole-dipole interactions. Whereas the hydrogen bonding between water molecule and ethanol molecule can take place. So this is a hydrogen bonding between water and ethanol. And these interactions are therefore reflected in terms of their physical property. For example, the partial molar volume that we have seen here. Coming to the presentation again. So in this way, I have taken the simple example of water and ethanol to understand the concept. So in this way, what happened? These properties, partial molar volume or partial molar compressibility, they are useful for understanding the